Okay, thank you everyone for coming. My name's Aaron Newman. I'm CTO and founder of a company called CloudCheckr. We're going to talk today about ways to help keep your cloud from ending up hacked, and what are the threats in today, and how do they change, and how do we handle those. CloudCheckr, we provide software to help you do a lot of this. So we have a booth down there. So after the presentation, come down. We're giving out some cool water bottles. We don't have any more today, but come tomorrow morning, you can get a water bottle and all that. So definitely come down, and I'll be there as well to answer more questions. So thanks everyone for coming. And as I said, we're going to talk about, what do you do in the cloud today? The world has changed. You no longer have these physical assets. Now you have these software-defined applications, software-defined networks, ephemeral, elastic assets. Things are changing. You don't have span ports you can plug into anymore. So the world is changing. We still need to secure our stuff. It's going to be a little different. So how do I go around securing business applications that are running in AWS? You have to rethink things. Everything from perimeter security. What is your perimeter in the cloud? It's not like we used to do in the data center where you could run a perimeter assessment. Your perimeter just isn't as well defined in the cloud. It's very different, very nebulous. So you have to think about how you're going to perform these same tasks. The idea of sniffing packets is very difficult in the cloud. The idea of doing IDS and IPS, very different model. The first thing I talk to when I talk to a security guy that's fairly new to the cloud, he wants to know, how do I set up firewalls and switches and things like that in there so I can monitor the traffic? And it just doesn't work because you don't own the infrastructure anymore. You have to work in the new model, and you can be much more secure in the cloud. The cloud can be much more secure. You have to understand how to use it, though, in an effective way. So you have to think about how you're going to do tasks like IDS. How are you going to do network scanning? How are you going to do penetration tests, VA tests? You still need to do them, but it's not going to be using the old tools and methodologies. You don't want to just think about securing your network. It's more about securing workloads that are running on the network. So you can't secure everything, and that's not even a new principle, but you have to put the right amount of security in the right places, secure your workloads as they're running in there. In the old data center, you would go and build a data center. You'd put a perimeter security guards. You'd have your internet connections, and those would be firewalled. You'd have all kinds of security set up that way. You'd audit the perimeter security. You'd have IP addresses that were fairly static, so you could poke those for holes. You could try various exploits. You could sniff all the packets that were going around, right? You own the network, so you could sniff them. Although SSL made that a lot harder, you still knew who was connecting to who. You had visibility into everything going on. You don't have that anymore. So what's different? The first thing is really the physical assets. You don't have to worry about, it used to be that you'd have to shred your hard drives, and you have to worry about somebody jumping a fence and breaking into your data center. You don't have to worry about that anymore. AWS is taking care of that. They have really tight security, better security than likely you had in your data center, they now have. So they've made that idea of securing it, the physical security, really is just, it comes out of the box. You get it for free. So things are really secured in availability zones, but they're now basically guarded by the idea of an API. So the Amazon API is very much, it used to be you would worry about somebody sneaking into your data center and stealing a hard drive or a server. Well, the virtual equivalent of that is somebody using the Amazon API to copy a snapshot or terminate an instance or doing something like that. So the Amazon API has become kind of a virtual, your virtual physical security. Your physical security is morphed into that. So the idea of physical security morphs as everything gets virtualized through these APIs. But what it means is your APIs have to be tightly guarded. The APIs, the AWS APIs are the keys to the kingdom. So if you're not protecting those, then it's the same as leaving your data center, no guards on your data center. So shared responsibility. So we hear about this a lot. The idea is using AWS does not mean you're secure. What they're doing is giving you the capability to be secure. So it's still your responsibility. They have a responsibility of making sure that the hard drives are properly secured, the servers are properly secured, providing you enough tools and services to secure it, giving you everything you can do over the network. They give you capabilities to encrypt. They give you capabilities to do everything very securely, but it's still your job to do the next layer down, which is securing the applications, configuring the right settings properly, using the right protocols. So these still remain in your control. And so when people say, well, you're running on AWS, does that mean you're FedRAMP certified? No, what it means is you can be FedRAMP certified because AWS has the FedRAMP certification, but you're still going to need to use things the right way. You're still going to need to run your application properly, use all the right controls to meet those certifications. So, I mean, what is security about? It's all about minimizing the attack vectors. So, these principles are the same. They're not going to change. You still want to reduce your surface area. Defense in depth. These are ideas that still apply to the cloud. You want to make sure that you don't leave everything wide open. The same way in your data center, you likely put a firewall up and prevented everything except port 443 through, or port 80. And the idea behind that was really minimizing the attack vectors. Attacks could only come, an attack on port 139 or attack on Telnet or FTP or SSH wouldn't get through because it was minimized. Now the same idea applies here. You want to make sure you have not just a perimeter, defense in depth, not just a perimeter, but you want to have layers of security inside of that. You still have application level attacks, so your same SQL injection attacks, your same operating system, things like shell shock and code red and those type of things, all still apply in the cloud. So it's just how you're going to allow access to them, how you're going to protect against those is really, you still have to worry about that, but things are changed. So the idea of your assets are ephemeral. What does that mean? So in the old world, you'd have 5 boxes. These were running your engine, whatever your application was running, and they didn't change. So if somebody owned them, there's this idea of advanced persistent threats. And this is like if you hear attacks on, for instance, Target, people were in there for 9 months. That was an advanced persistent threat. Somebody got 1 foot into the network, and then they used that to leverage leverage themselves further in, and they were there for a long time. And that's really where the danger with attacks is, when you see advanced persistent threats that exist for months and months and months. In a cloud, the world's a bit different because you have this idea of servers are spun up and then they disappear. So you have the elastic workload. It really makes it much harder for somebody to keep an advanced persistent threat in your network because they may take over a box. That box gets scaled down, gets scaled back up later as a different instance, and it really it's no longer under the control of an attacker. So there's a lot of things that change, those attack vectors, that make it easier for you to secure things. Perimeter assessment. How are you going to do perimeter assessment in the cloud? I mean, to start with, you really just can't take your scanner and start scanning the AWS network because it's against terms of use. And it's just not the right thing to do because other people have resources they're running out there, and you're going to start breaking other things, other people's applications. So it's just not something you should do, is to go running your SYN attacks on a box, even if it's running your application. You can't do that. You have to use the right tools, things like non-intrusive attacks that are not going to break things. You do have to go out to the AWS web page and actually register if you're going to run tests. And so registering it means you have to register with them, where you're going to be running the tests from. You have to make sure you agree to the terms to say, I'm not going to do tests that are destructive. And there's even instance types you're not allowed to run tests against. So you need to understand these and plan around them. So in the old world, you'd come up with a network block and you just start scanning it and see what's out there, and then start mapping it, and then start running tests against that. In the new world, really, the idea is now your network is software defined. So what does that mean? Everything in the old world, you'd send out packets and you'd look at the responses, and that would help you map a network. Not very an accurate way to do things. It actually can be, you can get a lot of false positives, false negatives, all that. So your network map was actually not very accurate. In the new world, you have this idea of everything's defined through the API. So you can actually get a very, very accurate picture of everything running in your environment. So that's a huge advantage, is you're not going to have to worry about, did somebody throw an app up that you don't know is running? If you're using if you're using the APIs, you could tell exactly what's running in your environment. Really, the challenge is translating all those things you're getting back from the APIs into what looks like an accurate map. because there's just a lot of moving pieces. You have to analyze security groups. You have to analyze your routing tables, network access control lists, your VPCs. You have to look at all the different services because many services don't run within the VPC. So really the challenge now is that we have a very accurate picture, but it can be a very complex picture. So you have to find ways to map that, understand it, and if you do that properly and if you do it very well, you have a very accurate picture and you can know exactly where all the holes are, and it's a very definitive way to make sure you're locked down. So one of the most important things to understand is VPCs. VPCs are really what you can put your resources in and lock it down. And the VPC is kind of logical. It's a logical cloud. It's a logical barrier to it. By default, you have one. In the old world, before a couple years ago, before VPCs, all resources were just kind of running and they were totally exposed. Other than through security, you'd have to protect it by a security group. But a VPC can be composed of different routes out. So you define how to get out, whether that's through the internet or through a VPN gateway. It has subnets, so within it, you have subnets that can talk to each other. You have routing tables of how they communicate. You have access control lists, which are firewalls, but they're stateless. Then you have security groups, which are host-based firewalls, but they're stateful. And then you have the resources that go in it. So it's important to understand, if you get the VPC, you probably have about 90% of your understanding of how to secure app. This is the security reference architecture. If you understand this, you have about 90% of what you need to properly architect securely in AWS. And here is a graph of this. If you understand this image, if you understand how the packets flow, where things sit, then you have a real good understanding. So go back, pick up the VPC documentation, and really dig through this, because this is important to know. I mean, you could see those subnets. You see within a region, you have VPCs. Within VPCs, you have subnets. Those define the IPs that live within it. And they have a route table that moves stuff around, a virtual private gateway to get out to the world, and then route tables within there. So understand that, and you can handle about most of the situations you're going to have to deal with. So you have to network within those VPCs. And the two most important things to understand are network access control lists and security groups. So NACLs, they have advantages and disadvantages, right? The advantage of a NACL is that you assign it once on a VPC, and everything going in and out applies to that. So even if somebody accidentally creates a resource in there and incorrectly assigns the security group, it can be protected by your network access control list. What are the disadvantages of network access control lists? They are stateless. So you have to define the traffic both ways. So when I connect to something outbound, I connect, for instance, to a web page on port 80. When it comes back on a different port. It's a high port, typically something above port 5000. So through your network access control list, you have to leave all the high ports open so that it can allow traffic to come back through. So you can see the disadvantage is you're not reducing the attack surface as much as you'd really like by having to say that everything above port 5000 I have to leave wide open. So that's one of the problems with network access control lists. As well, there's the idea of denies can be overridden by allows. So it's whatever rule comes first. So if I put a deny at the end of my network access control list, it says block everything on port 80, and then above it somebody inserts a rule that says allow port 80, the deny does not override the allow. So you got to understand these kind of intricacies. Now, security groups, you have to assign to every resource. So, but security groups they're basically host-based firewalls, stateful. So if I define people can get out on port 80, I don't have to define what comes back. So it makes it much more, I have a lot more control over what I want to restrict things to. The rules are also cumulative. So if you have a deny if the last thing in your list is a deny on port 80, it doesn't matter that somebody else inadvertently put an allow on port 80 before that. The deny is cumulative, and it will actually work. So you can see neither of them are perfect, right? Nothing's perfect in the world. What the idea is, you need to come up with strategies that use both of these, defense and depth. Remember my first slide there. So try to use the combination of the two to give you a better security posture. Almost everybody uses security groups, and we don't see a lot of people using network access control lists, and because they're just still a little bit of a challenge with the high port over 5,000, or if you're on Windows, it's an even lower port. So, but I continue to push people to look at network access control lists and use them more for that defense in depth. But right now, the problem again, though, is everybody's using security groups. So if you set up a VPC and you have 100 instances in there and they're all properly secured with security groups, tomorrow somebody comes in there and starts up an EC2 instance in that VPC and forgets to assign the right security group to it. Then that becomes a jump point to the whole rest of the network. One EC2 instance has exposed the entire VPC by one person's mistake. So versus with a network access control list, even if somebody comes in and does something bad like that, they're protected. So, there's some links, so go read more on these. Again, VPCs is the core piece to understand. The other piece to understand is, how do you actually connect to things? Obviously we're using TCP/IP, but what are the IPs that are actually assigned? An EC2 instance can have a lot of different IPs assigned to it, and understanding that is key to making sure you're not doing something that can expose you. When you start up an instance, you get an instance ID. You can't really connect to an instance ID, but you can use that through the Amazon API. So understand what the instance ID is. You can also have a friendly name, but now you start getting IP addresses assigned to it. By default, you get a non-routable IP address and a non-internet routable IP address. So that's a private IP address. Typically starts with something like 172. So that you can't access that through the internet. So that's a safe IP to have, where only people local on the subnet or in the VPC can reach. So, and that translates also into a DNS name that looks like that. So understand all the different ways that people can get to that. You can also give it one or more public IP addresses. And it used to be, when you ran what they called legacy EC2 instances, by default you'd get a public IP address assigned to it. So you had to be aware of that. And then you're going to see things like a 52.24, an IP address that looks like that, that can be routed to from the internet. So even if you have a 52 or a routable IP address, but if you have it blocked by the security group, then it's obviously still secure. But the question is, if you don't mean it to be publicly accessible by the internet, then don't give it a public IP address. So again, just defense in depth. These are things you ought to, don't give it a public IP address unless it really needs it. And then you can assign elastic IPs. So an elastic IP is, I go define an IP address, and then I assign it to an instance or a network interface card on that box, and then it lives forever. Because the IP address that is assigned directly to the EC2 instance, those get recycled. So it's kind of interesting, where if you have an IP like the 52.24.201.167, now if that auto scales down, 20 minutes later, somebody else in the Amazon infrastructure could actually be using that IP address. So be aware of that, and it happens the other way too, is if you spin up a new instance, they're likely reusing an IP address somebody else had used. So there's lots of interesting things that maybe somebody else is still trying to talk to that. So understand the ramifications of that. So really, if you want to be doing stuff from the outside world, you really want to be thinking about using elastic IPs, where you don't have to worry about things getting recycled, people trying to connect to an IP that somebody else may have been using earlier. So how are we going to run vulnerability assessment in the cloud environment? Because the idea is it's very limited what we can do, and even more important is, I'm going to have a workload that's elastic, and it may spin up 100 boxes today, spin them all down, tomorrow spin up another 100 boxes, and what am I going to do? Be running VA tests on every one as it comes up? No, that just doesn't work. So what we really need to think about is, how do we handle this? Is that we need to think less about scanning the boxes themselves and more about scanning the AMIs and creating AMIs that we consider scanned, right? Does that make sense? Where you can spin up an AMI, create an instance of it, scan it, check for vulnerabilities, and then consider anything spun up out of that really has this kind of the same stamp of approval, or is the it has the same validation that something else, that what you tested still applies to this. So even if you have a workload with thousands of servers, as long as you're properly spinning up the AMI, testing what's built out of that, and then using that, that can really be applied to the entire workload. Now, where does that break is that the longer the instance is running, it's no longer, if it's been 2 hours since it's running, there's very little chance that something was changed on it or it created a new vulnerability that you need to test. If it's been there for 90 days, then likely whatever you scanned the AMI off has deviated from what's running in that. Somebody may have logged on and used the browser, ended up with some kind of vulnerability or exploit on the box with a virus or something like that. So the longer the instance has been up and running, the less you can rely on the AMI that it was based off of. So does that make sense? So you need to come up with your own internal policies around not I'm going to scan everything in my environment, but how am I going to build workloads that are based on images that I can consider gold standard, scanned, reliable, and then how am I going to track when it deviates from those, and it does need to be something that I truly do scan. So those drifting away from the original AMI is your big problem there. So, and what do you do about patching strategies? How are you going to patch? The idea is you don't want to just patch instances anymore. The idea of no patch, there's a no patch strategy. That's what you really want to try to do in the cloud, is stay away from patching live systems. You want to patch your AMIs. And so what you want to do is spin up your AMI, patch it, save that as a new AMI, and then base your workloads on that. So does that make sense? That's a no patching strategy. It doesn't mean that we don't patch things. It means that we don't want to patch live systems anymore. We want to get away from them. The idea of systematic workload reprovisioning, that's a very important concept to understand, where everything you have in the cloud, you ought to be able to, all of it ought to be able to go away, and you just reprovision it using a script. That's the fundamental way that you want to deploy things in the cloud. And when you follow that, securing it becomes a whole lot simpler, because there could be a new vulnerability that's discovered tomorrow. Well, if I could just redeploy my entire infrastructure with one script, then I fix it in my AMIs, and then just redeploy the whole thing. Now that requires, of course, thinking about things from cloud architecture perspective. So if you just shifted and lifted from your data center, then that's still tricky, because you're going to have servers that are static, and you're going to have to end up patching those live. But really, get away from that. That's the key to making the cloud a more secure environment, is get away from static assets and get to the point where redeploying workloads is the way that things are done. And when you do that, that's where the cloud actually has a much more secure posture. It gives you a much better position in security than the old world. So if you're really just lifting and shifting, and you still have static resources that need to be patched in the same way, then you really didn't get any security advantage by moving to the cloud. If you think about things as redeploying these secured workloads and patching that way, you really get a huge security benefit. So what are we missing here? So the one thing you got to think through. So don't assume attacks only happen against Amazon, against EC2, or against VPCs. So AWS is a very big system with a lot of moving parts. There's over 30 different services. Some of them have their unique access control systems. So the idea is going to be, even if you lock down all your VPCs, well, did you lock down S3? Did you lock down SNS? Did you lock down SQS? Did you lock down workspaces? All those different pieces you have to lock down. So don't just focus on VPCs only, because the idea of the hacker, he's not going to go after your strongest chain in your link. He's going to find where your weaknesses are. You may have locked down all your VPCs and totally forgot you left an S3 bucket up there that's wide open. Or you're using a new service, DynamoDB, which doesn't sit behind a VPC, and he's going to attack that. So understand all that. The other challenge, you're going to have this distributed architecture with big organizations have hundreds, if not thousands, of Amazon accounts. So if you're locking down most of them, how do you make sure they're all locked down? Because again, the attacker's going to go after the 1 or 2 accounts that you're not securing properly, that you're ignoring. So, so for instance, RDS. So these are within a VPC, or they can be outside of the VPC, but there's security options like DB security. There's security options like publicly accessible. So I go ahead and say databases should never be publicly accessible. If you're going to open it up to the outside world, everything really should just be within the VPC talking to the database. If you're talking across the network, the internet, over the VPC, you absolutely have to be using a security group to restrict it to very small blocks. I mean, database is just not built to withstand internet level attacks. You know, services like web services, Apache, they've really been designed to withstand kind of the types of sophisticated attacks that you get from the internet. If you put an Oracle database or a SQL Server database out in there, there's just too many kind of well-known zero-day exploits against these. They're not robust enough to handle that. So you really want to keep your databases locked down to just your internal network. So make sure you're locking down your snapshots. You went and locked down all your databases, all your RDS databases, but you left your snapshots available, or exposed, then that's the same as giving away the keys to the kingdom. Somebody's just going to try to take those snapshots instead. So lockdown, think about not just where the databases sit, but where your backups are, all of that. S3. So you can have you can have 1,000 buckets in an account, unlimited number of objects, and this is on a regular basis. When I go out and I do a security review for a customer, somebody in the organization has left an S3 bucket wide open and said, well, I'm not worried about that, but it really can become kind of a jumping point into a network. For instance, people often, again, dismiss, these are read-only documents. There's nothing valuable on there. These are just HR documents, our employee handbook, right? And there's nothing in there that's valuable. But I've seen people with their employee handbook in a writable, internet writable S3 bucket, right? So what does that mean? A hacker finds that, stumbles upon it, changes the employee handbook to have some kind of virus in it. People start downloading that. Ends up with an advanced persistent threat in your network, things like that. So even if it's something you say, well, I'm not worried about, that's not sensitive data, you still have to lock it down. You still have to protect that. So S3 has every security option you could possibly imagine. Encryption, 4 levels of access control, server-side encryption as well as network encryption, logging, all of that, but you have to go enable these things. You have to use them. So just having them is not enough. Actually make sure you're using them. Don't ever grant full control, write ACP or write bucket permissions to everyone. The other thing is I also see people seeing this idea of there's authenticated user. Authenticated user means anyone, anywhere who has an AWS account. So if you grant permissions like write permissions to authenticated user, it's the same thing as granting everyone permissions to it. So understand what that means where you go grant it. SQS, it does not live within a region or within a VPC, so you can't secure it using a VPC, so you have to make sure. So that's an example of a URL for SQS. They have their own separate access controls. So you may have locked everything else down, and if you left a policy that allows everyone to do things like SQS send message, it becomes, a jumping point into the network. So be aware of the SQS policy documents. SNS, the same idea. It doesn't live within a VPC, so you can somebody can be granted, everyone can be granted permissions to do things here, and there's all kinds of vulnerabilities, application level vulnerabilities. Not vulnerabilities themselves in SNS, application level vulnerabilities where you're processing messages that are put on this. There's all kinds of injection attacks that can happen, things like that. So you need to be cognizant, and if anyone's ever saying, let's grant everyone permission, it's typically wrong. So you want to limit it to just who needs access. There is a lot of tools and different features from AWS that give you some really robust security. Things like CloudTrail, CloudWatch Logs, VPC Flow Logs. You got to turn them on, right? So out of the box, the first thing you should do when you start your Amazon account is enable CloudTrail in all the different regions. And then when they put in a new region, make sure you're enabling it for the new region, right? So if you're not recording things, you're not going to know when things are happening. And I see a lot of people actually will enable it just in the region they're using, right? Why do that? Why not enable it in all the regions? Because the idea is you want to find unusual activity, even if it's not in the region that you intended to. So go turn it on in all the regions. There's no cost associated with it. You know, if nobody's doing anything in those regions, it's not going to create any S3 files, so you're going to have zero costs. But you really need to make sure you're enabling it. And particularly I see in large organizations with hundreds of accounts, you know, 60% of them will have CloudTrail enabled. And there'll be 40% where it's not enabled.
So why is it disabled by default? Wouldn't it make sense to leave that enabled as, you know, default for the cloud?
Well, I mean, should it be enabled by default? I've had this discussion with some of the people on the CloudTrail team. I mean, there is S3 costs, so I think that they just don't want to automatically enable the S3 costs for you. But I think there is a good argument for it. But it's, you know, it's a good question. You know, I certainly think it would be better security perspective, it was enabled by default. It's just not today. They have really made it easy so that it's now a one-button click to enable across all the regions. So they've done everything they can to make this as easy as possible with one click to enable it in all the regions, but you still have to go into that one place and click it. So, but it's conveniently, everything that happens in Amazon goes through the API, so it absolutely is collected in CloudTrail, and you have records of it. So, you know, it's changed on a daily basis, but most of the services are integrated with CloudTrail. When they put out a new one, occasionally it's not, day one it's not enabled for CloudTrail, but then they work very hard to get it. So at this point, most of the services are, so you should be able to see data for any service, what people are doing. So even if somebody goes into the console and tries something, that will be logged, that goes through the API and is logged into CloudTrail. So you really have access to all that. Of course, even if you're writing it, the next thing is you have to be monitoring it, right? So you have to be knowing what should I look for, and you know, what are you going to do? Go open S3 JSON files and start looking for events? Not a very practical way to do it. So CloudWatch Logs is a cool new feature that they put out. It's been out, I think it's been out at least a year, but the idea is, used to be in, for compliance, you have regulations that require you to say, you have to keep these operating system logs for X amount of time, and different regulations have different amount of times. Now, think about your workload in AWS, where a Unix box is brought up, it writes a bunch of stuff to the operating system logs, syslogs, and then it's spun back down. The logs are gone, right? So how do you continue to meet those regulatory requirements? CloudWatch Logs, they give you the ability to ship your logs in your operating systems into CloudWatch Logs, which is not scaled down. That becomes kind of a place where all the logs are unified into. So to meet the challenges of, I need to maintain those operating system logs, yet I still need an ephemeral auto-scaling environment, they've written some, you have an agent you can put on your Linux or your Windows box that ships the logs into CloudWatch Logs and provides a repository. You can store them there for whatever your regulatory requirements are. Now, of course, the next question is, how do you monitor that? How do you maintain it? How do you make sure you're storing them? You know, so that's your job as part of the shared responsibilities model, is to go make sure you've enabled it, you install the agent on these boxes, and you're shipping the logs over. Another really cool feature that Amazon has put out is the VPC Flow Logs. So, you know, the biggest challenge from a security perspective is you don't have real deep packet content inspection capability. So you can't just put a span port into the router and see everything that's going on. So they have taken the first step, which is you do now have an exact, you have again, this is pushed into CloudWatch Logs, a full record of what IP addresses and what ports are connecting to what IP addresses and what ports in a VPC. So you still don't get the full packet because that's still a massive amount of data for them to store. But they do give you now who's connecting to who at the VPC level. And they also give you things like whether it was accepted, rejected, because before VPC Flow Logs, you wouldn't know Is my network access control list actually rejecting packets? Is my security groups actually blocking people? So, not having that visibility is scary because you may have set up your security groups right, but if you don't know who's trying to hack into you, who's trying to break in, not knowing that is dangerous. You really want to know when somebody's trying to do, and that's what VPC Flow Logs gives you. So it gives you a ton of other things. Like right now, you now have the capability to profile where all my packets are coming from. I can start to analyze things like what locations. I can monitor for things like blacklisted IPs trying to connect into my infrastructure. So you have all these capabilities, but you do have to, again, enable VPC Flow Logs. It is a lot of data, particularly if you have a high volume environment, and then you actually have to monitor it. So, tools for configuring. We're going to talk about CloudCheckr for just 1 minute, but generic tools don't work in the environment. You want to think about, you have all these great endpoint tools. You still need them. You still have to put endpoint protection on your boxes. You still need virus. You still need threat detection. You need all that. However, you still need to manage, to secure the management plane. And having all the antivirus and other protection on the endpoint is not giving you any security over your workload. So make sure you go out there, look for tools that are purpose-built for the cloud, understand auto-scaling, understand elastic environments, and can actually give you security in the right way. So something that has deep understanding of AWS, because context it's all about context. So you can take a generic logging tool and hook it up to CloudTrail, but if you don't understand the context of those, like what does the root account look like, what does it mean when something happens from this IP address? You need context to properly secure your environment. So go check out CloudCheckr's tools. Like I said, we have a booth here, and I'd love to give you a water bottle and talk more about what we do. But I'm going to take questions now. We have about 8 minutes. So we got plenty of time for questions. Questions on security or Amazon.
So does Amazon have a service that's comparable to DHS's continuous monitoring service where the systems are constantly scanned for malware and viruses?
That's a mouthful. I mean, they certainly have change monitoring tools. That's what AWS Config is one of Amazon's change monitoring tools. So it'll keep a track of every configuration change. Now, from the perspective of AV and malicious tools monitoring, they have tools they offer like Inspector, but doesn't really replace. It's a little bit different perspective what Inspector does. And we're really still on version 1 of Inspector. Inspector is a security profiling tool that helps you see what's going on there. But it doesn't replace what you're doing with your AV or your malicious, your rootkits and things like that. You're still going to need tools to do that today. The challenge there is, how do those tools work in an auto-scaling environment? Am I going to install an agent on a box that's going to be spun up 1 minute, spun down the next minute? So there's a lot of challenges for how security professionals are going to handle this. And so they work with a rich partner ecosystem. Everybody's from Symantec, McAfee, Trend Micro. Tools still work there, but it's still, you got to figure out how to fit it in. So. You guys are asking questions way too hard for me. That's like a 40-minute, so I guess I'd start with just saying, I don't have enough time to really answer that in depth, but the idea is use ELBs, and protect it by saying this ELB, I'm going to protect it by putting in a VPC. I'm going to restrict it to as few ports as possible to allow anything in. I'm going to only see the ports that are needed. I'm going to lock it down to that. That's the big piece. If you're doing that, that's 90% of it. And then, am I sharing keys between them? Do I come up with different keys for every communication? that's helpful, but probably if you're doing the smarter thing, which is just locking down your ELBs and restricting all ports but the only ones, setting up your security groups right, that'll get you 95% of what you need. Managing those keys is going to be a lot of work. So just make sure you do the other thing before you spend a lot of time integrating with KMS to regenerate keys and managing a key management architecture. That's very complex. So I don't know if that answers your question, but other questions? Somebody in the back?
So for encrypting, transparent encryption of like EBS or S3, I know there's AES, which is available by default. Why would you use KMS instead of AES? I know KMS is much more expensive. What fundamental benefit KMS over the default?
Well, so you're saying there's AES. AES is an algorithm that you use to do encryption. That's 256-bit. And it's the algorithm that's used. So KMS is a key management system. So I don't know if I'm misunderstanding your question or I think they're two entirely separate things. KMS is how am I going to generate keys, share them securely, how am I going to rotate them, things like that. Versus AES, I can enable AES on my S3 or on my EBS volumes, but then I can generate the keys myself and try to reinvent my own key management system, always a mistake. Or you can use KMS or what's the one, Cloud HSM, and use those to generate the keys that then you're going to feed into S3 or EBS, and you can call those AES keys. So I hope I answered the question. So. A little bit louder, sorry. Again, let me try to guess. So there's a lot of complicated. So privileged users is very important. Managing your privileged users, and by privileged users, I assume you mean Amazon, AWS privileged users, not operating system privileged users. Yeah. So your biggest threat in your Amazon environment, in my opinion, is your privileged users. Anyone who has the ability to do IAM policies, any of the IAM stuff is basically full admins. They can rewrite policies, and so there's a lot of complexity. So big thing is set MFA on anyone who's a privileged user in IAM. That's probably the most important thing you could do. If you know code spaces, look up code spaces. That's how the entire company got taken down, was because some hacker got IAM privileged access. So MFA is I think MFA is the critical piece. It's harder to say lock down every client because the idea of the cloud is you can connect from anywhere these days. So I've focused less on locking down clients and more of locking down how you get an MFA with whatever devices. So.
Similar to that question, how do you prevent, so say you have a developer that has the privileges to give MFA, or privileges to do IAM roles, and how do you prevent them from making a mistake or accidentally giving way too many rights? Or how do you respond to it quickly so you don't have to?
So if a developer has an IAM role,
He can make IAM roles.
right? So you need to, so segregation of duties, right? Nothing brand new. You got to segregate. Developers should not have rights to the IAM subsystem at all, right? So you want to break it apart into two roles: your DevOps team, and perhaps even, you probably have to assume role. You should be calling assume role to even get a role that has IAM rights to it. So you can't make the mistake unless you very specifically assume that role, and then only one set of users can create. Anytime you give IAM something, it usually means that person is a god on the system. So.
In the case of when you're doing development with Lambda, you pretty much
Right.
have to create a role, or you create roles for each single Lambda.
Right. So some of the services, for instance, Lambda, and I don't know this particularly, but if it requires you to create IAM roles, then you're giving God privilege to that person if you're letting them do that. So you don't want to do that unless you accept the risk of that. Maybe just put them in their own account where if you have to give them the IAM roles, go develop your stuff, and then they have to hand it off to somebody else to put it in there. But IAM is God role. So, question.
Could you speak toward IP reputation along the lines with like elasticity? You spin up an instance with a public IP address, 20 minutes later, that's gone. Do you have any recommendations or comments toward IP reputation?
I'm going to have to, they've flashing the red light at me. So come on up. Anyone who has questions, thank you for coming and check out the booth, please. Thank you, guys. Thanks. Let me ask his question first, just because he asked.